Hello friends, I am Dr. Sonal Chandak. In the last presentation, we discussed on the meaning and definition of hypothesis. In this presentation, we are going to discuss on one of the very important types of hypothesis. Rather, I should say that the most important, the relied upon type of hypothesis which is usually used when it comes to proving the hypothesis statistically, that is null hypothesis. Friends, let us try to know what is null hypothesis. A null hypothesis is a type of hypothesis used in statistics that proposes that there is no difference between certain characteristics of a population or certain variables of the population or data generating process. Let us go into more details to understand the concept in a better way. Suppose the average result of my university is 70 marks out of 100 and I wish to set a null hypothesis for my college, and it will be the average result of the university is equal to the average result of my college. Means if the average result of the university is 70 marks out of 100, for my college also it has to be 70 marks out of 100. And there is no deviation into it. The second example which I can take here for null hypothesis is in the game of cricket, the chance of winning both the teams is equal or same, that is 50-50. Here, the null hypothesis is neither of the team has the confidence of winning or neither of the teams can claim that they are going to win. There is an equal opportunity. It means the average winning capability is available for both the teams. Friends, let us take an example of gambling here. A gambler may be interested in knowing whether it is a game of chance of fairness or not. If it is fair, then the expected earning per play will be 0 for both the players. If the game is not fair, then the expected earning is positive for one player and negative for the other. To test whether the game is fair, the gambler collects the earning data from the different repetitions of the game and calculates the average earning from these data and test whether the null hypothesis that the expected earnings is now different from the 0. If the average earning from the sample data is sufficiently far from the 0, then the gambler will reject the null hypothesis and concludes that the alternative hypothesis, namely expected earnings per play, is different from 0. If the average earnings from the sample data is close to 0, then the gambler will not reject the null hypothesis, saying that the difference between the average from the data and 0 is explainable by chance alone. If the expected earnings from the gambling game is truly equal to 0, then any difference between the average earning in the data and 0 is due to chance. This has to be the null hypothesis. Friends, let us take an example of a school wherein 300 students are studying. Means here the population is 300 students. The school principal reports that the students of her school score an average of 7 out of 10 pointers in the exam. It means the average of the population, that is mu, is 7 pointers. To test the null hypothesis, we say that the selected 30 students as a sample, they also score the same, that is 7 pointers out of 10. It means the population mean is equal to the sample mean. This is the null hypothesis. It means that the school average and the class average or the sample average is the same. Then we start comparing the sample mean with the population mean, that is 7 pointers. We either accept the hypothesis or we reject it. The null hypothesis of the population mean 7 pointer cannot be proven using the sample data if it is rejected. Means either it is more or if it is less, then it is rejected. But if it is 7 pointers or very close to 7 pointers, it can be accepted. However, the null hypothesis in this particular case is the student in the school score an average of 7 out of 10 in examination. Friends, let us take another example of a mutual fund and its annual returns. The annual returns of a particular mutual fund is claimed to be 8%. Assume that the mutual fund has been in existence for 20 years. The null hypothesis that the mean return is 8% for the mutual fund. It means the population return is 8%. If we take a random sample of the annual returns of the mutual fund for say 5 years, that is sample, and calculate the sample mean. We then compare the sample mean to the claimed, that is population mean, that is 8%, to test the null hypothesis. If it is more, still the null hypothesis is rejected. If it is less, still the null hypothesis is rejected. But if it is 8% or close to 8%, that is within the level of confidence, definitely it is accepted. Here, the null hypothesis is mean annual return of the mutual fund is 8% per annum. Now friends, let us take another example of the investment strategy which my friend Jayanta says that produces higher average returns than simply buy and hold a stock. Means on one side, the investment strategy proposed by my friend Jayanta, and on the other side, buying and holding a stock. Here, the null hypothesis says that in both the ways, that is the proposed investment strategy by Jayanta and the buying and holding of a stock, both way it is going to give you the same returns. There is no difference in the average returns in these two methods. Whereas Jayanta is inclined to believe this until he disproves otherwise. Disproving the null hypothesis would require showing statistical significance which can be found using variety of tests. We can use tests, statistical tests, and we can prove. The alternative hypothesis would state that the investment strategy has the higher average return than the traditional buy and hold strategy. Here we have two different hypotheses. On one side, it is null hypothesis stating that there is no difference between the two average returns. On the other side, there is an alternate hypothesis stating that the investment strategy proposed by Jayanta has higher average returns than the traditional buy and hold strategy. Friends, the null hypothesis is also known as a conjecture. It assumes that any kind of difference between chosen characteristics that you see in a set of data is due to a chance. The statistical hypotheses are tested. They are tested using 4-step process. Step number 1 for the analyst is to state two hypotheses so that only one can be right. The second is to formulate an analysis plan which outlines how the data will be evaluated. The third step is to carry out the plan and physically analyze the sample data. And the fourth and final step is to analyze the results and either reject the null hypothesis or claim that the observed differences are explainable by chance alone. The analysts look to reject the null hypothesis because it is a strong conclusion. The alternative conclusion that the results are explainable by chance alone is a weak conclusion because it allows that the factors other than the chance may be at work, and therefore usually null hypothesis is more at work, more used by the analysts or the researchers.